these are what are called Pythagorean squares. If I can take three squares and arrange them in such a fashion that if I pair up three sets of corners and they make a right triangle, which is what we have in the middle here. So once I close this shape off, so that right triangle that's in the middle, which all of these sides, by the way, so this square, each one of these are squares, so these sides are all the same inside of these squares, because they're squares. Definition of a square. So at face value, it's not obvious. Why is a squared plus b squared equal to c squared? Pythagorean's theorem says that when I arrange squares like this, is that the sum of the squares, the sum of the smaller two squares equals the larger square. And it's talking about area. It's not talking about the sides. Of course, the area is related to the sides, but it's not about the sides. So what I can do is I'm going to sandwich this entire mess into another polygon that I can do area calculations on. So I'm going to put the entire set of Pythagorean squares into this rectangle that sort of looks like a square. Whether it is a square or not, you know, maybe I lucked out. Sort of looks like a square, but I don't know for sure. So what I can do is, you know, the sum of the parts equals the whole, right? So the sum of all the areas that I see in here has to equal the area I would compute if I knew the sides. So let me kind of section this off a little here. And I hope you can see that the area of this blue triangle is 1/2 AB, because it's a triangle. And we just learned area of a triangle is 1/2 AB. Well, I got news for you. This triangle, whoops, I gotta be more careful with the shapes here. So I gotta close these off for this bucket tool to work right. So that triangle is the same as that one, and this one. I have, whoops, gotta close that other one off there. So those four triangles, every one of those triangles has an area of 1/2 AB. So I'm gonna, when I compute an area, I'm just gonna close it in this way. So I know the area of those blue regions. Each one of those right triangles is 1/2 AB. And if you have 4 50-cent pieces, that means you got $2 worth, so to speak. So I have, if AB was $1, I have half a dollar, half a dollar, half a dollar, half a dollar. That's $2. All right. So I know the area of those triangles. The other easy kill would be these big squares that I started with. So let's see, what color to put here? I think I'll do a white bucket. So that area there has to be c squared, because it's c times c. It's a square. Every one of these things that have a, b, or c in them are a square already. So this one's going to be b squared, and this one's going to be a squared. And we can so those white squares are the ones that we originally started with, and again, a squared and b squared and c squared are areas of those squares. Now what about these other ones? Well, happens to be the case, you can see right here, area of this square has to be AB, because if you look right here, I have an A and a B, Those are the two sides of that square. Every one of these remaining ones is an area of AB, because that's my only choices, because of what they're next to. They're only next to A and B side things. All right. So sum of the parts equals the whole. You know this. You knew this before college. Sum of the parts equals the whole. So how would we apply that? Well, let's add up all these parts here. So it looks like I have 3 of the ABs. Well, first I'll do this. I'll do the easy ones. A squared plus B squared plus C squared. That's inside the big yellow box. I have 3 of the ABs. Those are the ones in yellow. I have 4 of the half ABs. Those are the ones in white in the blue area. That's all of the parts. Okay? So let me add that up. A squared plus B squared plus C squared plus 3AB plus 2AB. All right. Well, what is that? Has to equal the whole. How would that work out? We'll realize that I could talk about the area of this whole sum of parts as base times height, the yellow sides of this rectangle. Well, looks to me like I have an A plus 2, I have a 2A plus B side here, because this side right here is a B, and these sides right here are A's. So I have 2A plus B, and the other one is going to be B plus 2A. I'm sorry, A plus 2B. Those are the sides of my rectangle. So if I write the area, base times height, A plus 2B times 2A plus B, well then we just did there's some algebra to do here, so this is going to be 2A squared plus 4AB plus AB plus 2B squared equals all of this stuff over here. A squared plus B squared plus C squared plus 5AB. Well, I want to direct your attention to the fact that 5AB and a 4AB plus an AB, those are the same thing. Those are 5AB. They totally drop out. I don't need them. I can just get rid of them, because if I subtract one from the other, it goes to 0. And so now I have A squared plus B squared plus C squared equals 2A squared plus 2B squared. So if I subtract A squared and B squared from both sides, then what do I get? Well, all of that drops out to 0. And this right here, I'll have to scooch it up to the top because I ran out of space. But I'm going to have C squared equals, well, 2A squared minus A squared is just A squared. And 2B squared minus B squared is B squared. So I get the Pythagorean theorem out of this arrangement where I put the Pythagorean squares as they come into another shape and just do the sum of the parts equals the whole. And on the sum of the parts was counting all the individual shape areas, and that has to equal the whole area, which I can compute as a rectangle space times height, length times width, however you want to look at it. And when it all shakes out, it shakes out with the Pythagorean theorem formula. Now, you're not going to be tested on that. You don't have to reproduce it, but this is college, and we're supposed to deliver some knowledge at the College of Knowledge. So hence, I tell you where this stuff comes from. Some of it's easy to develop. I mean, this is tedious, but it's easy. None of it was like, crazy mathematics, but it gets easy to get mixed up when you're trying to figure out what's in A, B, C, etc.